Okay, so we've actually found all of our points here, and I can scrub back and I can scrub forward. I could just play this and you'll see that we have a variety of points here. And I'm just going to pause that and let's look at our graph. So our graph looks a little bit like this. You'll see we have our X and our Y, but the primary graph that we're going to be concerned with will be this Y displacement. So we have 1, 2, 3, 4, 5, all the way down to 10 different trials there. So 10 different points. And I say different points, but I should say trials because we have 1 point here and 1 point here. This is the initial Y. This is the final Y. And between those two, that's going to be our major Y. So enough of that. We're going to go ahead and go and take this video. And before we do that, I was going to let me go back to experiments. This is crucial. We are going to call this the conservation or initial velocity using the conservation of energy. All right. And I'll just be a little bit more explicit here by putting a period here and a period here. Hopefully all of the programs will take that nicely. So now if I go back in here, I am just going to take this on over to graphical. And then from graphical, we're going to go to Microsoft Excel. So right now, I just have to wait till it opens up. Okay. So we're going to go over here to our share button right here. Select that. And we're going to select our data file. And we're going to go ahead and open this in graphical here. So it's opening up in graphical. I'm not really concerned about the graphs and all of that stuff right now. But what I am concerned about is the table and processing this in Microsoft Excel. So here's our table. We need to send this over to Microsoft Excel now. So it is opening this up for us. And I'm going to go ahead and tap on Convert and Edit. I don't want to save this to OneDrive. I want to save it to Dropbox. And I suggest that you do the same. So right now we have our choices. And we could always duplicate it later if we need it to. It is connecting and hopefully it will connect. Okay. So I'm going to go to my Dropbox here and I'm going to go to physics. And then I'm going to go, and that's physics term 9. And then I'm going to go to initial velocity. And then I'm going to go to the conservation of energy. And so I'm just going to drop that into this location. And so I can access this file from Dropbox, which means I can pull it into all kinds of applications like numbers, spreadsheets from Google, numbers from Apple or Excel or any other kind of application. So let's go ahead and make this a little bit bigger so we can see what's going on here. So we see we have time here. Not going to need time. We're not going to need X. We're not going to need Y. And we're not going to need this one. So I'm just going to go ahead and hide my time and my X displacement. And then I'll do the same thing for my X and Y velocity. The only thing that I want to work with is the Y velocity or Y displacement, not Y velocity, but Y displacement. So I'm going to go ahead and wrap this. Let me see if I can pull this back a little bit. Wrap it again. And this isn't really super important. It's just how I'm doing things. And we know that this is in meters, so you want to be specific on that. All right. So the first thing that we want to do is we want to just go ahead and color code our beginning and final positions. And the reason why I do that is so that I can distinguish as well as not make a whole bunch of mistakes. So it should be close to 0 for the initial and then around 45 for the final. And you'll see that we'll do that each time. So this is directly connected to our ability to measure and how we measure, how we don't go back to 0 every time. You can try to get there, but measurement always involves a certain amount of error. So I have 2 more sets here. If for some reason you're missing a beginning and an end, that means it's possible that you actually touched a point in one location twice. You kind of skip going from the beginning and then the end, and then the beginning, then the end. So just know that that could be the case. All right, so if there's a bit of frustration that is presented to you, you may have to go back and do it again, but that could be right. Why? So all I'm doing now is inserting above because I want to do my displacement calculation here. So I'm going to give this a strong color, and that color is going to be something like rust here. And so I'm giving it a strong color, or dark red, blood red. And then I'm just going to say that this is equal to 0.452438 minus 0. So that's C3 minus C2. And then I can just go down, and you'll see that this gives me a calculation. So now I can just copy that calculation and then go fairly fast through here. So I can paste, paste, paste. I pasted format by accident. Well, it really wasn't by accident. I actually did it on purpose. Now, yep, this is working. So now with all of these are all of our displacements, and we want to at least get our average. So after I get the average, I'll stop right there. So this is going to be the average displacement in the Y direction. So we know that this is going to be in meters as well. And since we've already defined it, this will be fine. So I'm just going to go ahead and say equals to, and then I'm going to start typing in average. And we should get our information here. So number 1 is located here. Then I'm going to select on number 2. It's located here. Then I want to select on 3. And then I'll just go back to 1, 2, 3, and then I'll hit my comma, and I'll keep going through selecting these. Comma, selection, comma, selection, comma, selection, comma, selection, comma, selection. Now that's it. And this is going to produce our average calculation. And you can see it right there. We only want 3 decimal places, because that's the best we can do. We can read down to 3 decimal places. All right, in the next video, we will go into actually calculating our initial velocity.